right? So the next thing that you need to know is that what are the desirable properties of decomposition of a relation. So whenever you apply a normalization technique, right? So we are going to go for schema refinement, where you are going to decompose the complex universal table into different fragments, right? So whenever you perform decomposition of a complex relation into fragmented relation, we have to take care of two important properties, right? So the two important properties is like you have lossless join decomposition property and dependency preserving property, right? So what I mean by lossless join property, right? So whenever you apply the lossless join decomposition property, you have a relation capital R that is being decomposed into fragmented relations R1, R2 till Rn, right? So if the natural join of all the decompositions gives you back the original relation, then it is said to be lossless join decomposition property, right? So whenever you are going to decompose a complex relation into smaller fragments, you need to check whether you satisfy this lossless join decomposition property and dependency preserving property, right? So lossless join decomposition property is verified by taking the natural join of all the decompositions, and if the natural join of all the decomposition gives you back the original relation, then we say that it's going to be a lossless join decomposition, right? So let R be a relation schema with instances R. It is decomposed into R1, R2, Rn with instances R1, R2 till Rn. So if the natural join of the decomposed relations gives you back the original relation R, then it is called lossless join decomposition, right? So that is, if the natural join of all the decompositions gives you back the original relation, then it is said to be lossless join decomposition, right? So we have some exercises to work, like to check whether a decomposition is going to be a lossy join or lossless join decomposition, right? So before studying that, we'll discuss the closure property in we'll discuss about the closure property in a database system. So once you know the closure property, you will be able to work with this lossless join decomposition. Right. So the next thing that we'll study is going to be closure of functional dependency. So closure of a set, X closure is a set of attributes functionally determined by X, right? So closure of a set is going to be the set of attributes functionally determined by X, right? So for example, you have different attributes like roll number, name, age, department, and a lot of details for a student, right? So roll number determines name, right? So what I mean by roll number determines name? So given the roll number, you will be able to determine the name of the student, right? So roll number can also be used to determine the department of the student, right? So given a particular attribute, it is possible to find all the attributes that are functionally determined by that particular attribute. It's known as closure, right? So let S be a set of functional dependencies on a relation R, and let X is a set of attributes that appear on the left hand side of some functional dependency in S. So we want to determine the set of all attributes that are dependent on X, right? So for each set of attribute X, we determine X closure of attributes that are functionally determined by X based on the set S. X closure is find out on a particular set of data, right? So again, I have some example for closure property, right? So we'll study closure of a particular functional dependency so that we can work with a relation and check whether it's going to be a lossy decomposition or lossless decomposition. Right? So I have shared a bad document with you. It's visible, right?
Yes, sir.
Right. Right. So for example, suppose we have a relation R with attributes A, B, C, and D respectively, and you have some functional dependency. A determines BC, B determines CD, right? So we are expected to find the closure of all the attributes, right? So closure of one particular attribute is like all the attributes that are functionally determined by the particular attribute is known as closure of that particular attribute, right? So A closure is going to be A. A closure is going to be BC, right? So A can functionally determine the other attributes B and C. So A closure is going to be ABC. Again, B closure is going to be CD, right? So ultimately A closure is going to be ABCD, right? So using that attribute A, you can functionally determine all the attributes in that relation, right? So A closure is going to be A, A closure is going to be BC, and B can functionally determine CD. So A closure is going to be ABCD, right? So similarly, we'll find the closure for all the elements in this relation. So what is B closure? So B closure is going to be B. B closure is going to be CD, right? So BCD. B can functionally determine C and D attributes. So B closure is going to be B, C, and D. And then what is going to be C closure? C closure is going to be C, and D closure is going to be D alone, right? So D cannot logically determine the other attributes. So D closure is going to be D alone, right? Next, we'll check for AB closure. So AB closure is going to be all the elements. A determines BC, B determines CD, right? Again, you know that if A can determine any element, AB closure is going to be all the elements in the relation. Similarly, AC closure is going to be all the elements in the relation, or AD closure is going to be all the elements in the relation, or then we have B closure. BC closure. BC closure is going to be BCD. BD closure is going to be again BD, right? CD closure is going to be CD, right? Again, we'll check the functional dependencies for three elements. A, B, C closure is going to be A, B, C, D, right? So whenever A is there, A can logically determine all the elements in the relation. So A, B, C closure is going to be A, B, C, D. And then A, B, D closure is again A, B, C, D, right? A, C, D closure is going to be A, B, C, D. And then B, C, D closure is going to be B, C, D, right? So hope you can understand this problem, right? Closure, how to work with closure, right? So the second problem you are going to work with closure, right? So I will give you the exercise for second problem. You are expected to compute the closure of all the elements in a relation, right? So let me share you the second problem. So you are expected to compute the closure of the following set of functional dependencies for relation schema, right? We have a relation with attributes A, B, C, D, E, right? We have 5 attributes, and there exists some functional dependency between the set of attributes, right? So A can functionally determine B, C, D can determine E, B can determine D, and E can determine A, right? So now you are expected to work, and you are expected to give the attribute closure for all the attributes in this relation, right? So you can take a piece of paper and pen, and you can start working on it and get me the solution, right? So you are expected to find A closure, B closure, C closure, D closure, then AB closure, AC closure, AD closure, BC closure, BD closure, right? BE closure, CD closure, CE closure, DE closure, right? So you are expected to find closure of all the attributes in this relation. So this will help you uh, whenever you are going to work out with some problems, like to check whether the decomposition is going to be a lossy decomposition or lossless decomposition, and whether the functional dependency is preserved in the decomposed relation. We go for this closure property, right? So once you know how to compute the closure for a particular attribute in a relation, then only you will be able to solve that problem, right? So let me like ask students to get some solutions. Narasimha Reddy, Narasimha Reddy, Nanda Kishore, Nanda Kishore.
Yes, sir.
So can you compute A closure?
Hello.
Yeah, you are audible. Can you compute the A closure for this second problem?
Yes, sir. 1 second, sir. So it would be A, B, C, and A, B, C, then D, then E, then A.
Right. So A closure will get you all the elements in the relation.
Yes, sir.
Or, right. Can you extend it and find B closure, Nanda Kishore? So what is
Yes,
B
sir.
closure?
I'll try it, sir. 1 second. So B closure would be D, then yes, sir. Then BD. That's it. Because we don't have any more extensions for D, so that it would stop at BD.
Right. Right. Correct. And what about C closure?
So we don't have C like separately. We have C and D combined.
So C closure is going to be only C.
Yes, sir.
And D closure?
So that's also D itself, because we don't have D as a separate entity here.
Right. And finally, what is E closure?
So that's E and A.
So A can determine all the other elements in the relation, right?
Yes,
So
sir.
already
Yes,
we have find out A closure is
A
going to
closure.
be all the elements A, B, C, D,
Yes, sir. It would be A, B, C, D, N, E.
E, right? So E closure is going to be all the elements in the list,
Yes, sir.
right? So correct answer, Nanda Kishore. Thank you for your
Thank you, sir.
participation. Right. So next, we have to extend it with two elements, A, B closure, right? So we have done with this, right? A closure, B closure, C closure, and D closure, and finally E closure. E closure, since E can logically determine A, you will be able to get all the elements in the relation, right? Then we'll extend it with A, B closure, AC closure, AD closure. Here it's quite simple, right? So the thing is that since you know that A closure is going to be all the elements in the relation, AB closure is going to be again all the elements in the relation, AC closure is going to be again all the elements in the relation, AD closure will be all the elements in the relation, AE closure is also all the elements in the relation, right? Right. So now you can check with BC, BD, BC closure, BD closure, BE closure, and so on.
So rest everything other than BD closure will be ABCD all.
So you have done it, huh? Yeah, you are correct. Subramaniam, right? Yeah, you are correct, Subramaniam.
Vishwanathan.
Right. Right. So we have computed the closure for all the elements in the relation, right? So you can make a note of it. So closure property is important because we'll be using this closure property in normalization to check whether the decomposition is going to be a lossy decomposition or lossless decomposition, and to check whether the functional dependency, right? So whenever you decompose a relation, again you need to check whether the FD functional dependency is preserved in the decomposed relation, right? So there are two desirable properties of a decomposition. So whenever we have a complex relation and it has a lot of redundancy and it has a lot of anomaly, you are going to refine the complex relation into fragmented relations so that uh, there is less redundancy. There is no redundancy and there is no anomaly. However, whenever you need to decompose a complex relation into fragmented relations, you need to ensure that there is lossless join property in decomposition and dependency is preserved in a decomposition, right? So lossless join property means that whenever you decompose a complex relation or into some smaller fragmented relations, the natural join of the fragmented relations should give you back the original relation. It is said to be lossless join decomposition. And regarding the dependency preserving decomposition, so if there exists some dependency between the attributes in the base relation, right? So for example, A determines BC, or A determines E, and so on. So the dependency should also be preserved in the decomposed relation, right? So to check this dependency preserving property, we go for this closure property, right? So I hope you are familiar with closure property of an attribute now, right? So these are the two topics I plan to teach you today, right? So you need to know the introduction to normalization. You need to know whether an anomaly exists in a relation. So we have studied the different types of anomaly like insertion anomaly, deletion anomaly, and updation anomaly. So uh, you need to ensure that whenever you design a relation, there is no redundancy and there is no anomaly in schema design, right? So we'll continue in the next class. Next class we'll solve some problems regarding checking whether a decomposition is going to be a lossy joint decomposition or lossless joint decomposition. and we will study the second property also, whether the dependency is preserved in a decomposition.